Okay, the next keynote speaker is David Yen, Senior Vice President and General Manager of the Data Center Technology Group at Cisco. That covers data center switching, servers, and storage, quite relevant to what this conference is about. He is responsible for the Cisco Unified Computer System and the Nexus switching portfolio. David has nearly 30 years of experience in the technology industry. Before joining Cisco, he was the Executive Vice President and General Manager of the Fabric and Switching Business Group at Juniper Networks, where he led the Q-Fabric initiative in data center network. Previously, he spent over 20 years at Sun Microsystems. In the 90s, he led the development of the first and second generation multi-CPU SMP servers, which transformed Sun from a workstation company to a leading enterprise server company. Later, as head of Sun's microelectronics group, he revived the declining Spark product line, introducing the industry first 8-core 32-thread general-purpose processor and making it into a multi-billion-dollar business. He also managed Sun's storage business for 1 year. Yen had a Bachelor in Science and Electrical Engineering from the National Taiwan University, a master's degree and doctorate in Electrical and Computer Engineering from the University of Illinois at Urbana-Champaign. David.
Thanks for actually the invitation. It certainly is a great honor to be able to talk in this conference. And with my journey in Sun's servers, later Sun Microelectronics, the Hot Interconnect Conference was considered as a very prestigious conference. I usually only send my fellows and senior distinguished engineers to present. And so today I have an opportunity myself kind of present the journey we went through in the data center networking, and to share with you, even though many of you, I believe, are also going through this process, if not directly contributing to it. So, yeah, actually, you're right, I don't need it. So, in the next about 45, 50 minutes, I'd like to walk through something pretty dramatic. Originally being a server guy, only start entering the networking industry in a more formal way in 2008 when I joined Juniper. And yet, witnessing the entire data center networking going through this thing, it's very, very intriguing. First of all, if you look at this 5-phase kind of a technology evolution, the leftmost phase is pretty much what we in the industry, in the data center, are using, a multi-tier tree-like switching infrastructure, which basically is an evolution of the local area network. And you start with a simple network, and yet when your data center grows, when you need to interconnect more servers, more storage, more appliances, more routers, you need to scale up. So after deploying a lot of first-tier switches, now you need a second tier to interconnect these first-tier switches. Then before long, you need the third-level switches, and you keep growing that. This architecture, actually interesting enough, has been serving us pretty well all the way to about the .com period. In the very popular client-server model in the 90s, this tree-like architecture actually is very well behaved. The client requests coming from the outside probably enter the root of the tree and then find the appropriate path to go to the responsible servers, get the service, get the information, and then traverse the path to go back. Nothing gets wasted. Everything works just fine. Then the .com period started, the e-commerce, with the programming models, whether it's due to searching, whether it's due to the online banking, whether it's doing other things. The programming style started to trying to utilize all the available resources in the data center, all the available computing powers. So this communication and cooperation between servers themselves, between server and storage, becoming more and more frequent. So the traffic pattern is changing from the more traditional north-south type of pattern to be more predominantly so-called east-west. Now, when that happens, and furthermore, everything gets speed up, CPU become faster, and so then people started examine this switching infrastructure, first of all, for scalability reasons. It's not unusual for a typical data centers to have 4 or 5 tiers of switching. In fact, the largest one I saw 3 years ago in the data center, they have 7 tiers of switching switches. Now, particularly before just 3-4 years ago, each switching tier, the delay still costs you somewhere between 5 to 10 microseconds. Now you start thinking the communication between 2 servers interconnected with such a tree structure, from one server to the other server, in general, it has to go to the root or near some place in the root and then come back down. It's almost always the worst case type of thing, and things add up very quickly. When you have 4 or 5 tiers, easily you can get 50 to 100 microseconds of delay. So the latency started to become unbearable. And along with the increase of latency, not depending on where the server is on the transmitting and the receiving end, now the latency become more unpredictable. If you are lucky, the 2 are right next to each other, you can communicate very fast. When you are on the other end of the data centers, you may have to go through a much longer delay. So the performance of the application become less predictable. And also with a larger multi-tier tree structure, the management, the provisioning, all become much more complicated. And when you try to provide some security services, now you have a coverage issue. Where do you put the firewall? And those within the umbrella are covered. Those are without, you're out of luck. But most importantly, though, there's another issue. And we talk about the internet convergence. You think that's bad. But after all, people are not necessarily using internet. Well, until if you're monitoring your heartbeat through Amazon, that's a different story. But in the data centers, when you use the traditional networking protocol, which actually started as a distributed protocol designed for a distributed system, so you behave like you don't really know the overall picture, and you try by handshaking, and gradually you build up the knowledge for the whole environment. In the data center domain, you really don't need to do that. And yet, up until recently, in fact, 90% of the data centers today in the whole world are still using this multi-tier infrastructure and running, guess what, spanning tree algorithms, which is designed to eliminate redundant paths or eliminate loops so switching can behave appropriately. But in the data center, people like redundancies. People want redundant thing of everything. Well, until recent cloud programming style, that's yet another topic. But people want redundant paths. But the spanning tree algorithm will actually actively disable your redundant path, only invoke them when failure actually happens. Then you have to go through a convergence window. A very high percentage of networking failures in the data centers are caused within that finite convergence window when the spanning tree algorithm is running. So people don't like it. And from an investment perspective, if customers have already invested in those paths, they want to utilize all the available bandwidth. So you better deal with these redundancy issues. So with all of these things, around 2005, on top of that, virtualization technology is being used more and more popular, and the virtual machine moves. They want to move not just among all the servers within the same rack. They actually want to go elsewhere, potentially to another server in a different rack at different places of the data centers. And nowadays, they even want to go beyond your data centers. So in this case, this kind of a design, you even face the problem that if you want to maximize the mobility of the virtual machine, you want to enlarge your L2 domain. But level 2 protocol is designed with the flooding, with all these other things. You have a very large failure domains. So a lot of the issue, it forced the networking vendor started paying attention to say, what is the right architecture for us to design the network specific for the data centers? So at that point, which happens around 2005, 2006, not that long ago, then people say, well, so in the data centers, all networking equipment pretty much belongs to the same owner. We got to be able to do a better job than the way internet is constructed. And we better be able to design a networking technology which actually avoid the spanning tree algorithm type of protocol, allowing you to utilize all the available bandwidth. And furthermore, while you need to scale to very large scale, the latencies not necessarily have to be identical from any point to any other point, but they have to be within such a tight range. They are both predictable and also reasonably equal so that you don't see a significant variation when you run the same application. So a lot of the fabric technology now is offered by multiple networking vendors with different degrees of attributes. Start paying more attention to design it for virtualization, for scalabilities, and also for dealing with the redundancies. And that is pretty much state of the art until recently. And this is the second phase of the fabric network. Now, after a while, after the customer can get the fabric technology from multiple vendors, then the whole thing reach a higher, more mature level. People say, well, it's nice. I can now have a more predictable delays. I can scale to a very significant size. But the whole provisioning, the whole thing is still too complicated. It's still manual. And when I provision the compute, the server is one way, provided networking is another way, provide storage is yet another way. These are disjoint processes. So what customer is paying attention to now is beyond the scalability, beyond the redundancy. Now they literally are looking into the total cost of ownership. In other words, they are demanding efficiency. So technology has further evolved to a point that the vendor's responsibility is to take what has been achieved in the fabric technology and yet trying to further simplify. The detailed technical necessity is still there, but the vendor's responsibility is somewhat through automation, through integration, to provide a better abstraction to the customer, to the user, so it makes it easier to use. Pretty much at the same time, and we are still in this, the OpenFlow got invented. The software-defined network concept started to emerge. And what is the desire of this software-defined network? In fact, when OpenFlow was first invented, Cisco's reaction was, what is this thing? Okay? Is this just a whole bunch of students think they can write a better BGP than the professionals? And But after a few months of reaction, after all, with Cisco's large customer install base, we talked to a lot of customers, a couple hundreds of them. Why are you interested? What are you trying to do? Then eventually, we find the beauty of this whole thing, which actually I will elaborate later. This is why several months later, in June 2012, Cisco announced the open networking environment. In fact, not only we are going to support OpenFlow, we will actually provide a superset of API called Cisco Open Network Environment Platform Kit, or 1PK. It's an API with the SDK to be implemented across all the Cisco switches and routers, not just in the data center, but in the campus, in the service provider network. So we created a window. And on top of it, since not everyone has the capability or prefer to program on the assembly language level, pardon me to use server analogy, and more capable service providers, whether they are telco service provider or content service provider, they can. They have hundreds of thousands of IT professional in-house, but a lot of customers out there, either it's not their competency or they don't want to invest in that area. So you need some additional help. You need some additional software module which take care of a bunch of generic middleware things, and then through a northbound API, hopefully industry standard API, allow people to program, to manage this network on a higher level semantics. This is equivalent to programming in a high level language. So along that thing, within Cisco One framework, Cisco also announced we are going to provide the controller agent. And then on top of that, you can use OpenStack, you can use vCloud Director, you can use Microsoft System Center. There's a whole bunch of high-level management software. So this is the emergence of this route. Now, all of the intent here is to give the outside world, on one hand, to simplify, on the other hand, to give the outside world to inject the business objective or special application characteristics. So with such a desire, time is right now for a new technology to evolve. This is the thing that Cisco actually, together with the spinning in CME Networks, announced a couple months ago in Cisco Live Orlando, the so-called application-centric infrastructure. Basically, the basic concept is building on top of the success of Cisco's unified computing systems. I'm not going to elaborate on the UCS, but very interesting listening to the Facebook presentation on the Open Compute project. With enough knowledge, with the kind of a particular environment, you like to further optimize by disintegrate all of the thing. And yet there are a significant number of customers and segments there. They actually need the vendor's help for them to integrate the system together to avoid their dealing with the individual boxes. So the Cisco's unified computing system, the basic concept is build a stateless hardware, integrated them together with a well-designed converged network, and then have a piece of management software on top of it called UCS Manager. And this piece of software, through various templates, which collects all the necessary parameters which you otherwise will provision the specific server in terms of the server management, storage management, network management, from the addresses to the driver version number, to the particular OS, to the hypervisor, to even the order you want to boot the system. All collect in this template so that now you can, whenever you want to provision the whole system, you just click, select the right template called service profile, and then instantly you customize a particular server to run in a particular way for a particular application. with today's cloud computing, and that's a tested and proven model. In fact, in 4 short years, Cisco, using UCS, was able to go from 0 revenue, 0 position in the server space. In 4 years, Cisco now is the #2 x86 blade server worldwide. 1 out of every 5 x86 compute blade is Cisco UCS blade. So with this tested and proven formula, now you take it, raise it to the top of the cloud computing data centers. Now you look at for each application, and depending on the application's special characteristics and what kind of a web and infrastructure requirement and the security characteristic you need to deploy. And this part is very important because the data center security model also have transitioned from the old-fashioned castle model. All you have to do is put a gigantic firewall at the perimeter. You are done. Keep the bad guy out. But for economics, for sharing, all data centers now want to run multi-tenant. By sharing, you reduce the cost. It's going to be run more like a hotel model. You want to open up your front door, you welcome people to come in. But hotels still have to enforce security. Except now the security has to be enforced in a much finer granularity. You have to look at every individual who walks into the door. Who is this guy? What is this guy? What is he or she trying to do? And what he or she trying to access? And you have to operate in that fine granularity. So when you use a template approach, in fact, it will even force you, before you deploy an application in the data center, to think through all the requirements, including security, and then build them, embed them into this template. And then next time, when you run the application, or by the less knowledgeable operators, they can just pick the right template, apply to provision, orchestrate, and direct the data flow for the whole center. So that ushers in a next level of thing, and some of my colleagues call this is 2nd generation software-defined network. The 1st generation software-defined network, whether it's by Nicira or by the Cisco open networking environment, you can argue it's fundamentally trying to emulating the network environment by itself. But for the ultimate purpose it tried to achieve, that is trying to provide enough abstraction and taking in the application requirement to better perform, to optimize the application. In that case, the application-centric infrastructure provide a different way, and yet to achieve the same purpose, and this different way is probably much more direct and much more elegant. Then ultimately though, and this part is kind of a Cisco's party line, again, even though 10 years ago at Sun, I was already talking about sensors and traffic lights, these days with lots of cameras everywhere, you have one in every one of your pocket, and then we have cash registers, all these huge amount of data comes in. So they are all ready to be finally connected to the internet. You are talking about Internet of Things, Internet of everything. So we expect ultimately you will see these federation of cloud, not beyond just individual data center, individual cloud. So this is kind of a 5-phase technology transition. Today, in the remainder of my talk, I will elaborate a bit more in the 2 parts of this. One is the fabric simplification automation. The other one is the open network environment. And I saw on the agenda the CTO of Insieme Networks, Tom Etzel, tomorrow is going to go into much more detail, and you will hear directly from the horse's mouth about the Insieme innovation in the application-centric infrastructure. In fact, Tom is the person who even initiated the simplification technology that I was going to talk about when he was still at Cisco. But I want to conclude this thing by making a very important observation. When I, 2008, first joined Juniper and started talking to the real networking professionals, and the networking guys all pounding on the chest. Well, just like when I saw the storage guys, when I was managing Sun Storage, or when I was on the compute side, everyone thinks they are the king of the data centers. But frankly speaking, until the network opened up, what is the role of networking inside the data centers? Frankly, from an application guy, from a server guy who runs the application, the networking is very much a bunch of passive interconnect. Once I decide what services I need to deploy, I choose the appropriate application which can render such services. And in order to run such an application, I pick my preferred servers. And server needs storage to provide the data or to store the result. Oh, eventually, of course, all these things need to talk to each other. So they need to be interconnected together. But once they are interconnected, in a way, all the data flow are at the mercy of the networking protocols with the networking gear to direct the traffic. So it's a bunch of passive interconnect in a sense. But think about it, with the software-defined network, with the OpenFlow, with the Cisco's 1PK, when the networking devices open it up, then you can program directly toward it or through a controller software as a tool. Now, with the fact that the data center network, after all, does interconnect all of these networking resources, be it server, be it storage, be it router, be it services, appliances, and yet you can control it now. That literally transition the data center network from the role of a passive interconnect now becoming a strategic control panel for you in the cloud data center. In other words, through the interconnect networks, now you can provision, you can orchestrating, you can directing the entire operation in the data center. That is extremely strategic. This is why Cisco's CEO, John Chambers, at one point, he was saying, the software-defined network is the best thing ever happened to Cisco. This is very different from some of the superficial Wall Street analysts, their view that software-defined network seems to trying to invade the traditional networking, and Cisco as the incumbent vendor, obviously Cisco is doomed, and nothing is further from the truth. So I couldn't help picking this topic because 25 years ago when I was at Sun, it was right at the point Sun was saying the network is the computer, which was considered by many as a pretty visionary statement. Except when Sun says it, the network was local area network. The computer was a collection of workstations. You do get the productivity, you do get your compute. But now think about it, with the network role within the data center, with this API, with this dialog window, the way you can control it. And you think about what cloud is offering you. The network is the cloud. Okay, now I want to dive into two specific subjects, and just to give you some a deeper understanding of this. And this is a whole bunch of networking equipment Cisco offers, the networking switching product. 1,000 is the virtual switch, 2,000 to 6,000 are fixed switching, and 7,000 is modular, and then the MDS fiber channel directors. And in the last 12 months, this is, you can consider as innovation of the phase one, still the traditional multi-tier tree structure. Cisco did roll out the switches offers the lowest latency. In fact, it will offer a latency any port to any port less than 250 picosecond. And for Wall Street financial applications, for their specific use, you can actually further reduce the latency down to 190 picosecond. So the switching delay, particularly when you consider how much time you spend in TCP/IP, spending other things, started to become literally zero now, that it should no longer be your concern. Cisco also introduced the Nexus 6004 several months ago, which offers the highest 40 gig port density in a 4RU configuration. And we also started shipping the 16 gig fiber channel director products. And most recently, 2 months ago, Cisco introduced the largest single chassis core switch in the industry. The backplane can actually provide a throughput up to 83 terabits per second. And one single chassis can accommodate up to 384 40 gig ports or 192 100 gig ports. That's the state of the art of our data center networking capacity. But what's most interesting thing that we are developing, though, to further promote the art of the network in the industry, Cisco has been offering the data center network under the banner of Unified Fabric. The reason we are talking about the Unified Fabric started from the invention of Fiber Channel over Ethernet in 2006 at Cisco. So with the Fiber Channel over Ethernet, the idea is we should no longer have different network carrying different kind of a traffic in the data center. Just like on a 8-lane, 10-lane highways, to maximize the throughput, you really should not have rigid limitations. Say, pickups can only work on the lane 3 and the 4-door sedan should only run on lane 2 or lane 1. So it should be a unified framework. We are not quite there yet. Even in this conference, people talk about InfiniBand, people talk about fiber channels. But step by step, that is the idea. And over the years, Cisco contributed a number of inventions. But as I said earlier, up until this latest technology, the customers still complaining the provisioning process is manual, and it's a disjointed provisioning when you provision different parts of the data centers. Some of the software overlay or the first wave of the so-called software-defined network, the way they are promoting it, while the idea seems to be intriguing, they have significant fallacies because you rely upon the CPU to emulate the network operation. You consume a lot of CPU cycles, which means it is not as scalable when you started to grow the size. If you have a huge ACL list, as some of our customers are, you are in tough luck. But the most fatal fallacy of a pure software implementation is you lose that connection between hardware and software. When you have problems, failures, or even when you're just trying to understand where's the bottleneck of your network, you lose that correspondence between your logical abstraction and your physical underlay infrastructure. And when you're trying to grow your network, expand your scalability, a lot of time that expansion process, not failures, a non-expansion thing is a disruptive process. You need to reboot the whole network, which is disruptive. And overall, the whole provision is pretty static. So all of these translate to complexity, translate to architecture rigidity. If you want to maximize the virtual machine mobility, you want a large L2 domain, but that brings a large failure domains. You want to use layer 3, so you have a small enough failure domain, but that may not be that easy to migrate to float your virtual machine. What you desire to do tends to dictate what network architecture you use. So a lot of efficiencies, this basically point out, again, to be more mature, this whole fabric network design has to be further simplified to automate and improve. So this is the fundamental motivation for Cisco 2 months ago announced our dynamic fabric automation technology, or DFA. Actually, without getting a lot of detail, this is not a place to do it. But fundamentally, the whole concept is actually very simple. Although various topologies are supported, but the base architecture is based on a two-tier span and leaf architecture. And this is not a new invention. Cisco's fabric path already using this topology. Arista, Andy Bechtolsheim, several years ago has been advocating a two-tier spine and leaf architecture. You can view all the spine nodes are a large distributed backplane for the whole data center network. The leaf node, every leaf node is connected to every spine node, which means, first of all, with this architecture, no matter where your servers and the information is located, they are within no more than 2 hops. So the latency is confined to be a very predictable and manageable range. The leaf node actually represent the edge of this physical switching network. We bring the layer 3 protocol all the way down to the leaf node, and the layer 2 actually terminate at the leaf node. In other words, every leaf node interconnect with all the server, storage, services underneath it and improve. So this is the fundamental motivation for Cisco 2 months ago announced our dynamic fabric automation technology, or DFA. Actually, without getting a lot of detail, this is not a place to do it. But fundamentally, the whole concept is actually very simple. Although various topologies are supported, but the base architecture is based on a two-tier span and leaf architecture. And this is not a new invention. Cisco's fabric path already using this topology. Arista, Andy Bechtolsheim, several years ago has been advocating a two-tier spine and leaf architecture. You can view all the spine nodes are a large distributed backplane for the whole data center network. The leaf node, every leaf node is connected to every spine node, which means, first of all, with this architecture, no matter where your servers and the information is located, they are within no more than 2 hops. So the latency is confined to be a very predictable and manageable range. The leaf node actually represent the edge of this physical switching network. We bring the layer 3 protocol all the way down to the leaf node, and the layer 2 actually terminate at the leaf node. In other words, every leaf node interconnect with all the server, storage, services underneath it. But all the chatty layer 2 protocol terminated right at the leaf. So the forwarding in this physical switching network is actually using IP addresses. Therefore, there's no need for spanning tree algorithms. You are actually doing routing in this switching network. Now, so interesting thing is now the VLAN become a local concept, only meaningful within each leaves. Different VLANs pertaining to the same application or the same project now got correlated together through a 24-bit segmentation ID, which can be derived either from Cisco's fabric path encapsulation protocol or from the VXLAN. And both will be supported and utilized to create that 24-bit ID to associate with different individual segments within the leaf. And finally, communication outside of the network will go through specialized leaf called border leaves. So this is the construction. Now, to provision such a network, it's all through a single point of management point, interesting enough, without too much creativity, engineer called CPON, central point of management. So through that central point of management, all the network configuration information or services can be provided to switches grouped by type or by their role in the network. So that means whenever you have a large-scale software update, you really don't have to touch individual boxes. You can provision in groups. But more interesting, all the switching components within this configuration, whether they are spine or leaf, they all support a capability called power-on auto provisioning. In other words, all switching nodes in this configuration needs to have the ability to configure themselves in the network once after cabling and power on. So upon booting, they will automatically go to an external server, fetch the configuration information depending on the type of the switches and their role in the network. So after power on, all these switches will start to participate in the networking protocol to connect with the rest of the switching fabric and also connect them with the associated servers and storage. So this is a zero-touch automatic provisioning. In fact, with such a capability, even if you have a cabling errors, it will be detected and resolved based on profiles you can customize ahead of time. And further interesting enough is whenever you use a high-level management software to provision a bunch of virtual machines or physical machine for that matter for a particular project, at the same time, you will create the corresponding networking configuration and services information. So later, when the server administrator provision a virtual machine or something, the networking characteristic will immediately be provisioned at the same time. When the overall configuration detect a particular virtual machine or physical machine for a particular project, the appropriate networking characteristic or requirement will be provisioned to the responsible lead. And furthermore, when the virtual machine moves, the network actually have the ability to reapply that network information to the new responsible lead for that particular virtual machine. Everything is automated. So this is the latest kind of improvement to make the whole network configuration much more automated and much more simplified. I won't bore you with the next level detail, and this is a kind of just a graphic representation that whenever you provision the virtual machine or physical machines, the corresponding networking policies and the characteristics will be provided to the leaves, and when the virtual machine moves, that policy will also move correspondingly. The final piece I want to elaborate a little bit is the Cisco Open Network environment. We did announce it 1 year and 2 months ago. What has happened since then? And this is basically just says now we have a closed loop system. It's no longer open loop. In other words, the network will collect a lot of information, deduce a lot of analytics, cycle by cycle, packet by packet. Such information now become accessible by the outside world and then blended with the policy or business objective, and in turn, through the programming interface, can inject back to the networking devices to alter or to direct the traffic. So this is a closed-loop system, and within the umbrella of Cisco Open Network, I said we will provide the programmable API called Cisco One PK across of our all switches and routers. We will be providing the controller agent sitting on top of OpenFlow and the 1PK to facilitate the customer using it as a tool, and we will also expand our virtual overlay using our virtual switches, the Nexus 1000V. we announced at the end of January this year in London, during Cisco Live London, that later this year, we will release a commercial available controller software that customer can use as a tool on top of these APIs. Since then, at that time it's called Cisco One Controller. Since then, Open Daylight Consortium was formed. Cisco actually donated the bulk of the code we developed for this controller, which we intend to commercially release, to the open source consortium. If you look at this very detailed architecture diagrams, all the modules, including the southbound API module, the service abstraction layer, which separate the southbound plugin APIs to different switches and different modules, and the whole collection of middlewares, which are generic, to do things like physical to logical topology, translation, to provide a whole bunch of other generic network services. And the top highest layer is individual service modules, which we do retain them, because this is Cisco's value add. Just like all the other Open Daylight Consortium members, they will all contribute their specific expertise to build their individual modules on top of this Open Daylight infrastructure. And so everything denoted in the light blue are what we donated to the Open Daylight Consortium, and the one in the white part is what we retain. And this commercial version of the Cisco One controller will be released next month. And Cisco will stand behind it, will support it. And yet the whole thing is built on top of the Open Daylight open source infrastructure. In terms of the southbound API, initially we will support the OpenFlow, the industry standard OpenFlow, and Cisco's 1PK. But if you dig into the detailed technological architecture, what we actually did was build a open 1PK layer on top of all of Cisco's network operating systems, whether they are NXOS or different flavors of iOS. Then the architecture is designed, you can have different specific plugins sitting on top of the 1PK, because 1PK is a superset. So even the OpenFlow is a plugin module sitting on top of 1PK. And yet the whole architecture is flexible enough. Over time, we potentially will plug in some additional modules to support different preferred API that people want to use to different boxes. When we release the commercial version, basically the Cisco One controller will support three major use cases. One is slicing. And this one is very similar to the original motivation when OpenFlow was created. And so you partition a shared physical network into several logical partitions. That means anything happened in one logical partition will not affect other part of the logical partition, highly preferred by the campus CIO, so that the computer science student can do whatever they want, but they won't affect the production network in the campus. But turns out, even in the commercial world, even in the professional service provider network, there's significant interest of these kind of a partition technology. The second major use case is monitoring. We call network tapping. As I described, with a lot of middleware support, now you can program with the northbound API, which allow you to focus and to develop more sophisticated monitoring, analytics, or debugging module. But a very interesting application is called custom forwarding, because now you can access a lot of detailed information. For example, one attribute the Wall Street is most interested is latency. And if they can get precise timing information through IEEE 1588, through these things at the ingress and at the egress of the network. Now they can offer premium services to the customer, guarantee a very tight latency range. Otherwise, they will carve out a special path for you. Universities can use the custom forwarding to decide whether certain traffic is allowed to bypass firewall or not. One university, as a member of the United States high-performance computing community, when a huge amount of HPC data comes into that university, either from the East Coast or from the West Coast, they don't want the firewall to get overwhelmed, and they want them to bypass. Many universities have multiple campuses. They don't always want to pay the high cost to direct the traffic. If you are running video conferencing, that's mission critical, then they use the shortest latency, the high quality network. If the student is watching YouTube, I'm sorry, you do have to go onto the internet and maybe circle half of the world and come to your destination. But now you can intelligently direct and optimize for the cost of your network. So with all of these, and this last slide is commercial, and since we constantly push the envelope, no surprise in June, the marketing research firm Synergy claimed that for the first time now, Cisco overtakes IBM and HP as the top cloud hardware providers. And no surprise, the number 2 market share in x86 blade server also contributed to this position. So I think that's my presentations. And I'm pretty much out of time. But if there's any question, I'll be more than happy to answer them.
Anything? Nothing at all?
I'm trying to understand why you need a southbound abstraction layer and one PK, or I guess one PK as an alternative to OpenFlow, instead of just OpenFlow as your southbound interface, if this is supposed to be an open, multi-vendor, interoperable solution.
Yeah, very good question. Obviously, whenever there is an industry standard, particularly in the networking business, we want to support the standard. Except you all know, first of all, standardization process is a long process. Also, there's a tendency to be common denominators. And on top of that, as long as different networking gear, different vendor have their special ASIC or special hardware, there are certain information only they can provide and not provided, accommodated by an industry standard protocol. So that's why I said earlier, Cisco's 1PK actually goes beyond what the OpenFlow interface can provide, and yet literally deliver all the necessary parameters to the Cisco's customer. Now, we understand standard is important. This is why wherever 1PK API is provided on our switching and routing gear, OpenFlow will be provided at the same time. And customer also feel better that way, because in the worst case, even with the superset, if they have to roll back to a standard interface, it's always there. And now with the Open Daylight Consortium, in fact, Cisco now can not only its own contribution, whenever an open source consortium member contribute the state-of-the-art, the best OpenFlow implementation, we can benefit from that too.
Yeah, go ahead.
I have a question. Maybe I have a segue question to the Open Daylight contribution from Cisco. Do you have plans to open up the Cisco ANE agent side as well, or just the controller side?
Well, we'll be probably happy to open the 1PK implementation, except that's only interesting to Cisco customers, not the general community. we did contribute the OpenFlow 1.0 implementation.
Right.
That's what we had at the time. And my understanding, I'm not an OpenFlow expert. In fact, Cisco's engineering CTO, David Ward, is heavily involved in that. My understanding is at least a couple Open Daylight Consortium members are going to contribute the OpenFlow 1.3 implementation, which, certainly all the OpenFlow, Open Daylight Consortium member can benefit. So, the standard part is already open, even with our implementation. Our proprietary part, I don't know how much of an interest it is to open to the outside world.
I have a little bit of a visionary question. I want to see your vision on that. What is your opinion on heterogeneous data centers where you have heterogeneous networking equipments in the data center?
This is a very subjective opinion. If you like to call it visionary, I'm honored. 33 years in the industry. Most of you are too young to even know that. And in the old days, I believe in the 60s, 70s, it's not even generic servers. There are special purpose machines, database engines, and so forth. And yet, over time, volume always dominates. As long as the general purpose thing becomes fast enough, and then through software, you can customize it. So the special purpose computers started to disappear. They are all general purpose computing now. The networking side, same thing. And I'm not a veteran in the networking industry, but I heard enough. In the IP space, many of you are expert in the internet. In the late 90s, there's frame relays, there's ATMs, and eventually more and more now seems to consolidate, and the service provider primarily invest on IP. In the data center networking, it's no surprising, come with all kind of an optimized special purpose network. And yet, with today's information exchange, everybody is learning from each other. Things are not really that unique and differentiate anymore. And yet, if it's different technology, it still impede on your utilization, the way you're balancing your node. So personally, I'm a strong believer of, although it takes time, because IT is a business that the professionals are most conservative, because their job is to maintain the stability, maintain the service to their users. So any technology adoption in the data center tends to be slower than what actually happened in academics or in the research environment. It's fun for me to talk about this transition. In fact, the push toward the right are primarily pushed by the resourceful, dominate large customers like Facebook, like Google, like Amazon, like Yahoo, like Microsoft. But the majority of the data centers, including well-known major telcos. 1 week ago in Cisco's EBC, I gave a presentation, I talked about this transition. And the CIO of that company looked at me and said, Dave, what do you think? What's your guess of where my company's network belongs to? Where is it? With some knowledge about their environment, and yet to be a little bit polite, I said, well, my guess is you probably are between the phase 1 and the closer to phase 2, but primarily still phase 1. Then he immediately turned around to ask his team, say, Tim, where do we think where our network is? And they all look at each other. Then they say, well, David is probably right. So the bulk of the network is still in this multi-tier tree structure. Now, that's actually the good news, because when the technology has been pushed, now become more mature toward the right, when you're trying to migrate, you try to upgrade your infrastructure, you don't have to follow this evolution path. You can go to the more mature technology. So from so-called phase 1, you don't necessarily have to go to phase 2. You could go straight to phase 3, this highly simplified automated one, or even go into phase 4, the application-centric infrastructure. You pick the best technology and yet fit your attitude, your specific environment. So this is a long answer, but you probably know I am a strong believer of a more unified, more homogeneous, because the general purpose technology, because of the volume, always will dominate.
Any other questions from the audience? I will ask then the last question. So you mentioned about the standardizing the northbound API. So how likely do you think this is going to become a reality? Or will it take? Or is it going to be up to Facebook to disaggregate that or disintegrate?
No. I'm no expert for it. I'm only a disconnected engineering executive, so don't dig too deep into it. But I'm actually very optimistic with my understanding with even the Open Network Foundation. After the OpenFlow, multiple iterations of it, they also started looking at the northbound API. There's probably not many choices there. So with all the initiative, including the Open Compute initiative, all these are refinement for the standardization of the IT protocols or IT configuration in the industry. So all these will contribute. I actually feel that eventually there will be some commonly adopted northbound API. We are talking about less than a handful of years, but it's not going to be tomorrow.
Thanks so much
Thanks.
for your insights and